So let's have a look at scaling when we're talking about topography. So we're looking at this cornea. We can see that we've got green colours in the centre going out towards blue at the outside, and there is some red down at the bottom here. And these colours are represented by the scale at the left-hand side. You can see that the red colours we've got down here are shown as being around about 6.9 millimetres, 6.75, and then the blue colours around the edge of the cornea are 9.38. So this scale goes from 9.38 millimetres to 6.75, and that's fixed. So every cornea we look at, the scale will look the same. And this is the standard curvature, and it's an absolute scale. So these numbers never alter. And these numbers are shown in millimeters, but they can also be shown in diopters. So if we go to tangential power, instead of being in tangential curvature, you see the green, the color map doesn't really change very much, and the scale, the numbers go from 50 diopters down to 35 diopters. So this is the standard range, and they're just a conversion, direct conversion between diopters and curvature. So we wouldn't expect a cornea to have central curvatures of 9.38, and we wouldn't expect an average or normal cornea with central curvatures of 6.75. So this is a really good scale for detecting abnormal corneas that you're looking at. So if we look at this map, we can see that we've got an abnormal cornea. So we have a very red area in the middle, and this is obviously keratoconus, surrounded by blue all around the edge. So the cornea is going off basically at both ends. And in actual fact, if we click on the sort of middle of the cone here, we can see that the scale there is, the radius is 5.81 millimeters. And the scale only goes to 6.75. So we're losing information about what's going on in the cone in this area. But again, this tangential plot and then the standard curvature is how we screen for normal patients. And normal patients should have greenish colours or colours in the middle of the scale in the middle of their eye. Let's have a look at a different cornea. And so this one is, now it's a regular eye, it's symmetrical, so the top looks the same as the bottom, the left looks the same as the right, but there is redness there. But this is not keratoconus because it's symmetrical, so this is just regular astigmatism, but it's a very small cornea with Ks. If we bring in the Ks of 6.53 by 7.52. So it's a regular astigmatic cornea with very small Ks. And if we look at this cornea, we can see that this is also regular astigmatism, but with very big Ks, 8.99 by 8 millimeters. And if we look at these two corneas side by side, we can see that this is where a fixed scale makes things a bit harder to see, because every cornea is going to fall into a different part of this scaling. So if we've established that we're dealing with a regular cornea and we want to know kind of how regular it is, what we can then do is if we go into the axial plot, the axial plot is going to take away, there is a video on this on map types, it's going to take away any of the kind of odd extreme numbers that we're going to get on a tangential plot. So these really big numbers that we're going to get out at the very edge and they're effectively artifacts. If we go to axial, it's going to remove them, and we're then going to go to a normalized scale. Now let's just look at one map. So let's look at this very flat cornea, and we're going to go to a normalized scale. So a normalized scale means the topographer is going to pick the steepest part of the cornea, and it's going to allocate it the steepest colour, and the flattest part, and it'll allocate it the flattest colour. And you can now see, if we go between this, what was a very blue, very flat cornea, and the very small, steep cornea, you can see that they're now comparable. So we go to axial measurement and a normalized scale when we want to see sort of how normal is normal. And this can be really good for showing up asymmetrical astigmatism, or if you've got inferior steepness of the cornea, but it's still almost a normal cornea. This is a really good scale for highlighting that. So it shows you how normal is. Another useful thing with scale that we're going to do is I'm going to look at a comparison map. So we're going to look at an ortho-K patient, but this is also good from the point of view of progression with keratoconus. So we're going to do a comparison between this map on the left is pre-ortho-K wear, the map on the right is post-ortho-K wear, and we're going to do a comparison. And this is the comparison map of these two. And you can see that we've got a scale that's going from -3 to +3. And let's just change this. A good way of doing this is just to go for a normalized. Let the topographer pick up the normalized scale. And you can see there we've got the scale going from 2.82 diopters to 2.82. And this shows us the treatment zone created by the ortho-K lens. Quite a lot of, if you get this scale wrong, if we change the scale, you can see that we've instantly made this treatment zone look better. It makes it, you assume that you've got an uniform power over this whole center area and a very big treatment zone, but actually you can just see that the treatment zone is getting cut off at the bottom of the scale. So a -2 to +2 scale is inappropriate for this amount of ortho-K. Whereas if you select a normalized scale for this, it will give you an appropriate scale. And if this patient was around about a -3 amount of treatment we were trying to correct with ortho-K, then this would be a good scale. If we had a -6, again, the topographer in normalized would just choose the correct scaling for that patient. So that's the scaling. We've got either units are either in millimeters or in diopters, and the scale at the left can either be fixed or it can be normalized, and you can go into and change it in the measurement software through this button, whether you want an absolute scale or a normalized scale. Thanks for watching. Check out the other videos in this topography series as well.